The topic that we're looking at is vectors in two dimensions. So there's two things that we work with when they're in two dimensions. One is finding f res, the resultant force, or finding the components of a vector. So we've done, what you can see here, is we've done these two. So you can either have, let's say, F1 that is moving vertically, and you can have F2 which is moving horizontally. Okay. If you have two forces, one moving vertically, one is moving horizontally, what we can use is the head to tail method. Okay, if we're using the head to tail method, you can do this graphically, or you can do it mathematically. Now we know that if you're going to do it graphically, we need a scale. We work on a Cartesian plane, and the Cartesian plane usually helps us with finding the direction. And when we do it graphically, we use instruments like rulers and protractors. Okay, and that's how we do our measuring. If we do this mathematically, we know that to find magnitude, we can use Pythagoras. Or if we want to find direction, then we can use trig ratios. Now, we've been working graphically and we've done a bit of mathematical work. And sometimes if you look, we're looking at example 1, you have one vertical, one horizontal. And then what we find then is we find the resultant vector. And how we do that is that f res is drawn from the tail of the first vector to the head of the last vector. Okay. So we've got the R. So remember f res, like I said, you can call it f res. You can also call it R. It just means resultant vector. We use f res. R is just a different format. And what we also need to make sure is that we draw theta in the correct place. And theta is always between f res and the first vector. And that there is then your theta value. Okay, that helps us because then when we do trigonometry, it helps us to identify where's the adjacent, where's the opposite. If you have a diagram number 2, that's a bit different. You have multiple vectors. Some of those vectors might go horizontally, some of them might go vertically. And what you don't want to do here is, if I look at F2 and F4, they're in the same plane of each other. So what you want to do is simplify your forces that go in the same direction. So if I've got, if I look at F1 and F3 and F2 and F4. So what we don't want is a complex diagram like this. Because then when we work out resultant vectors, you might have a problem. So we normally simplify. For example, we would say that f res in the x direction is going to be equal to f2 plus minus f4. If we're saying that to the right is then considered as positive. If we say that up is considered positive, then f res in the y direction is going to be equal to f1 plus minus f3, and that should give us, like I said to you guys before, you're going to have f res in the y direction followed by f res in the x direction, and then like I've said, we're going to draw our f res completely from the tail of the first vector to the head of the last vector. So we now know how to find the resultant vector. So the new thing that we don't know is what happens if they give you the resultant vector and ask you to find all the vectors that make up the resultant vector. Okay, so what that looks like is, just a disclaimer, make sure that everything that's in this video is in your books, that you use a ruler and a pencil when you do all of your diagrams. Don't forget arrows. Don't forget to include theta values. Label all of your vectors. Make sure everything is in your book. Notes, examples. You can use as much color as you want. Remember, you're working in your books, and then you do the homework exercise at the end. And what we call this is the components of vectors. I just want to say sorry about my voice. I'm losing my voice. It's a little bit hoarse. So anyway, components of vectors, right? What happens is they give you F raised. So what we've got here is 10 newtons. And the 10 newtons is the resultant vector. Okay. Now, that's the vector that's been given to us. The question is going to say is, you're going to see quite often, is solve this vector or force into its components. Now, if we understand the word components, or what we're looking at is what are the changes? So that's the question. What are the changes horizontally or vertically, or rather let's say, and vertically, that cause this resultant vector? And we spoke about it in class yesterday. And what you can actually do then is say that this vector is actually caused by a force that is going horizontally and a force that is going vertically. Now, when I say the components, okay, right, all it is, the components, oops, sorry, let me just change the color there. The components, we can say, represent the combined vertical and horizontal forces that combine to make a resultant force. So that's all that it is. How do I get it? It belongs to certain components. Now, when I look at this triangle, what I can see is that I have an angle here. And if the upper angle is 30, then the lower angle is 60 degrees. And over here, I've got my 90 degrees. Now, this red vector over here, that vector is on the horizontal component. So it's on the x-axis. So what we call that is fx. Okay, f subscript x. And then the top one, because that's on the vertical and the vertical is the y-axis, we call that fy. Okay, now how do I find those components? What are their formulas? Now, their formulas are actually derived from trig ratios. So I'm going to show you, instead of having to do a full trig calculation, what we actually do is we manipulate the trig ratios to suit what we need in physics. Okay, so let's say I have this diagram and I want to find fy and fx. Now, I know in terms of right angle triangles, fx, because there are two angles over there, is the adjacent of the triangle. And fy, that's going to be your opposite. And this 10 newtons here, this f res that they've given us, that is your hypotenuse. Okay, so that's okay, that's what this triangle represents. So if I wanted Fy, okay, so the goal is to find Fy. Now Fy is the opposite, so I can use any trig ratio that has the opposite, and it must have f raised, which is your hypotenuse, because that's what's going to be given. Your f raised from your hypotenuse, that is given to us. We've got to use that hypotenuse and the angle theta to find each of the components. So if I look at trig ratios, I've got sine theta is equal to opposite over hypotenuse. But like I said to you, we're not using opposites and hypotenuse. We have different labels. So we can say that sine theta is actually equal to Fy over F raised. Now, I need to manipulate this because the goal is to find Fy. So what I can do to both sides is multiply each side by F raised over 1. Okay, F raised over 1. And the one side, it cancels out. And I've isolated Fy. So I can say that therefore, Fy is equal to F raised sine theta. So this here becomes the formula for the y component, or we can call it the vertical component. Okay, so that's your first formula. Okay, then if I wanted fx, okay, if I want fx, I know I've got to work with the adjacent and the hypotenuse. Just remember, adjacent is fx, that's what we want, and the hypotenuse is still going to be your f raised. This time the ratio changes now. Now we've got cos theta is equal to adjacent over hypotenuse, so we'll rewrite that in terms of physics and say cos theta is equal to fx over f raised. And what you're going to do is the exact same thing. Isolate your x component, right, by multiplying both sides by f raised, and then fx is going to be equal to f raised, which is our given value, cos theta. And that makes the formula for the x component, or we can call it the horizontal component. So when I say to you, I only want one x value and I want one y value, it's because at the end of the day, one x value and one y value make up a resultant vector. We can simplify, and up to this point we've been working at multiple different angles. But if I'm looking at f raised itself, I can work out the components that make up that f raised. Okay, so like I said to you, you have two major formulas that you need to write down. Please highlight it. Is fx is equal to f raised cos theta, and fy is equal to f raised sine theta. Now, like I just said to you, when we're working with this section or this type of thing, your fy or your fx, these are the forces in the horizontal and vertical directions. Okay, f raised is the resultant vector or resultant force, and your theta values are the values between the first vector and the resultant vector. Now, instead of using trig all the time, we simplify these formulas. We manipulated the formulas, so we don't have to do full trig ratios and do crazy mathematics. We can use these formulas as they are. So just remember, when I'm looking for fx, or I'm looking for fy, or vx, vy, or delta x in the x direction, or delta x in the y direction, these values here all have units. Right? The units can be newtons, they can be meters per second, they can be meters per second squared, they can be just meters by themselves. So if I'm using force, then I'd have newtons. If I'm using velocity, I have meters per second, acceleration meters per second squared, and delta x is in meters. So I'm just going to show you a few examples and then we'll move on from there. Okay, if you have a look at this question over here, this is example 1. It says solve this vector f into its components. So I've got the vector, and remember these are always sitting on a Cartesian plane. So it's sitting on a Cartesian plane. Sorry, I'm just going to draw in a little mini Cartesian plane. And if I look at it like this, I can see we're starting at the origin here, and what they've drawn here is the resultant vector. Resultant vector. Okay, and in this case, we are dealing with the resultant force. So the resultant force is 300 newtons. The question they're asking us is solve this vector f into its components. Now, I can have a look here and I can show you that in order to make this resultant vector, I had to have a force in the horizontal direction called Fx, and going from the head of that vector, I'm going upwards, and what I've got is the vertical one, which is Fy. Now they want you to solve it into components, so you're going to say we're going to do it mathematically. We don't usually work graphically when we work with components, mostly mathematical methods. So we're going to say fx is equal to f res cos theta, and in this case f res is 300 degrees and it's cos 60 degrees. So remember, just pause, put in your calculator, see if you're going to get it right. Alright, so that would give us 150 newtons, and we can say to the right, okay, because I can see in the diagram. Then we're going to say Fy. Fy is equal to F res sine theta. And I'm going to say 300 sine 60 degrees. And that's going to be equal to 259.81 newtons. And that is going up. So there are your two components. And that is how you get an F res and you solve it into components. Now, in this situation, there was only one F res, right? What happens when two objects or one object is being pulled by two F reses? So, two people pulling an object. Let's have a look at that situation. Okay, so example 2, it says, two men are trying to move a rock. The angle between the two ropes is 90 degrees. Calculate the magnitude and direction of the forces. So you've got Joe over here and he's pulling. They give you the diagram and they say that he's pulling at 70 degrees. And they give you Pete and he's pulling at 40 newtons but at 20 degrees. So we know the angles. Remember what I said. We must know the angles and we must know the F res. So basically what's happening here. So I'm just going to write here technically what's going on. All right, so what you are given is two resultant forces. Okay. Now, each resultant force each resultant force has its own components. Okay. Now in this case, let's show you how it looks, right? If I have my little mini Cartesian plane over here, and I'm looking just at Joe. Joe is pulling from the origin, he's pulling upwards, and he's got it at 50 newtons. Now that force is going in the x direction, so Fx, right? And it's also going in the y direction, so it's also going Fy. Now that means when I'm looking at this, the Fx is going to the right and the Fy is going upwards, okay? And this angle here is 70 degrees that we're looking at. However, the other guy, Pete, he's doing, so this first one here that we're looking at, that's Joe and what he's up to. The other guy, Pete, he's also pulling. Right? And except when he's pulling down here. Let's give it a little bit more edge. Right. So now we have Pete. He's pulling with 40 newtons. Okay. Now, that vector is doing two things. First of all, it's moving in the x direction. So it's moving in an fx. It's moving horizontally. And the other thing that it's doing is that he is moving downwards vertically. So now he's got an Fy. So I can see that in terms of Pete's situation, he's also got an Fx. His Fx is going to the right, but his Fy is going downwards. Now they want the resultant. Now you've got two forces. We've done this graphically before, but this is how we do it mathematically. When I have two forces and they want you to find F-res, the resultant vector, mathematically, we have to make sure that every component is sorted out into its x component and its y component. What is it doing horizontally? What is it doing vertically? Now what I notice now is I've got some information. I mustn't forget to put in our angle, and that's 20 degrees. When I'm looking at it, I've got two Fy's and two Fx's. And remember what I said. If you want to solve the situation graphically, you need to sort that information out into one x component and one vector in the x direction, one vector in the y direction. And here I can already see that I have two of each. So what they want us to do is find the overall resultant. That means that these two resultants create four components: Fx, Fy, one for Joe, one for Pete. And what they actually want is where would this rock actually move if these two people kept pulling it? So the first thing we have to do, and we're going to do this in steps. Right, so step 1. Okay, we've got Joe, and he's got an Fx, and he's got an Fy. And we've got Pete, and he's got an Fx and an Fy. Now, what do we know? So about Joe, we know that his F-res is equal to 50 newtons, and his theta value is equal to 70 degrees. Okay? When we look at Pete, his F-res is equal to 40 newtons, and his theta is equal to 20 degrees. Okay, so let's have a look here. The next thing we have to do in your step 1, once you've written down your information, always make sure you write down what you have and what you want. So, step 1 is write down your information. Now, here's your problem. It might seem trivial in this case to write down information. Always write down information. Build good habits, because you're not going to have 2. You're going to have up to 7 people doing their own thing on one object. Okay, so what you don't want to do is get yourself into a position where you don't sort out your information, you're in trouble. All right, then step 2. Step 2, we need to choose a positive direction. Let's set that properly. Now, you've got Pete and Joe are pulling at an angle, but those angles can be sorted out into components. So, you've got, for Joe, you've got an fx that's going to the right, and for Pete, you've also got an fx that's going to the right. For Joe, you've got an fy that's going up and an fy for Pete that's going down. Now, you have to choose a positive direction. So for this situation, I'm going to say anything that moves to the right is positive, and anything that moves upwards is then positive. So once I choose my direction, this here must be indicated to the marker. Because if you don't put a positive direction, and when you write your final answer down and you have a direction, it must be in relation to something. It's like, you know how we state the scale? We have to state your positive direction. Okay? All right, then step 3. Step 3 is we need to resolve each force into its components. Okay, so if I look here and I look at Joe, I want to find Joe's fx and fy. So I already know that Joe's f res is 50 and his angle is 70. So I'm going to say for Joe, fx is equal to f res cos theta, and his f res is 50 cos 70, and that's going to give me, make sure you have your calculators out, his fx is going to be 17 newtons. The next thing is fy. His fy, again, make sure we write formula, substitution, final answer. F res sine theta, so that's going to be 50 cos, sine 70, okay, and that value is going to give me 47 newtons. Okay, then we have Pete situation, exactly the same. He has an fx, and we're going to say f res cos theta, and his f res was 40 cos, and his angle is 20 degrees, and that should give me 38 newtons. And then you've got his fy, and remember, you want to do these by yourself at some point so you can practice. He's got also an f res sine theta for his y direction, and you're going to say 40 sine 20 degrees, and that's going to give you 14 newtons. Now let's look at directions. For Joe, in his x direction, it's moving to the right, and his y direction is moving upwards. Pete's, his f direction is also moving to the right, and his fy is moving down. Now this up, down, right, left, it's going to help us with step 4, because step 4 is then called vector addition. Now remember what I said, you can only have one x, one y. So when I'm looking at these values, I can see that I don't have one x and one y. I have 2 of each. So I've got to do vector addition. So I can say that f res in the x direction is going to be fx of Joe. Look at how I'm subscripting. And plus fx of Pete. So fx of Joe was 17 plus fx of Pete, that was 38. And in the x direction, my resultant force is going to be equal to 55 newtons to the right. Alright, so that's F raise in the x direction. Then we have F raise in the y direction, and that's going to be Fy of Joe plus Fy of Pete. Okay, now Fy of Joe is going upwards, so we're going to say it's 47 plus, but Fy of Pete is going down, so we're going to say minus 14. Okay, because it's going down, you have to have a negative value. So your F raise in the y direction then is going to be equal to 33 newtons. Okay, so now 33 newtons, and because it's a positive value, it means up. Okay, so that's step 4, vector addition. Step 5, remember, we need to find the resultant vector of these two people that are pulling. So in order to find the resultant vector, you need magnitude and you need direction. Now, I've got a force in the x direction and I've got a force in the y direction, which means that automatically tells me I can make a right angle triangle. And that's why I can use Pythagoras. And for direction, I can use trig. So let's see how this is going to look. So what I have to do now is I have to do a sketch. It doesn't have to be to scale. It just needs to be a sketch because I need to see where theta is. So what I do is I draw myself a little Cartesian plane. That's going to help me to see where theta is. Now I know that in the y direction, F raise is 33 newtons up. So that's F raise in the y direction is equal to 33 newtons. And coming straight off that, going to the right, is F raise in the x direction, which is 55 newtons. Okay. I also know that F raise must be drawn from the tail of the first to the head of the last. And that's my F raise. Now that's the resultant vector that we're looking at. Now, I can't keep doing things graphically. I need to do things mathematically. So this is what we call simplifying those massive four forces that are following one another. Rather, we can simplify it and make it into two forces, make it into a right angle triangle, and we can do it mathematically. So graphically, you can follow one vector after the other and find F raise, but mathematically, we have to get to this triangle. So you need one Fx and one Fy. Now here's your 90-degree angle, and I know that theta is drawn there between the first vector and F raise. Once that's sorted out, I can then look at it and I can say I need F raise, its magnitude. Okay, so in order to find the magnitude, I said we're going to use Pythagoras. We're going to say F raise is equal to, and we spoke about this, the square root of Fx squared plus Fy squared. So square root Fx was 55 newtons squared plus Fy, which is 33 newtons squared. So therefore, F raise is equal to 64.14 newtons. Done. Magnitude. So once the magnitude is done, that's fine. The next thing that I need is the direction. Okay, because it's a vector, I need this direction. All vectors must have magnitude and direction. Now when I'm looking at my little triangle here, and I look at where the angles are indicated, it tells me that Fy is my adjacent. And Fx is then my opposite in terms of trigonometry. Okay, because now we took a situation where we were given two f raises. Those two f raises then had to be sorted out into x components and y components. Once it's sorted out into x and y components, you have to do the vector addition, and then we get one fx and one fy. Now, when you do your diagram, and if you do your diagram, you will notice that just because it's fx and fy doesn't mean that it's automatically going to be cos and sine, or whatever the case is, or opposites and adjacents. Because if I look at the second diagram, and let's say, for example, I now said I drew fx first. So here's my fx, which is equal to 55 newtons. And then I drew fy, and that goes upwards. Like I said, choose your directions now. And then I go and draw f res over here. The angle theta is over there now. Okay? And your 90-degree angle's there. Making your fx then the adjacent and your fy the opposite. So it matters. Both diagrams are correct. The difference is when we write direction, we must either write direction in terms of bearing, or we might write directions in terms of compass directions. Now, both of those diagrams have a theta. Both of the theta placements are correct. It's when you write your statement that you're going to have a problem. Okay, so when I'm looking at direction, I can see that the only two things that I have is adjacent and opposite, which means the only ratio I can use is tan theta. Tan theta is equal to opposite over adjacent. So I'm going to work with this diagram. You can work with either one. You can do both if you want. Either way, I should get the same answer. So I'm going to say the formula we're going to use is tan theta is equal to the opposite, which is f res in the x direction, over the adjacent, which is f res in the y direction. Now, remember I said we're not going to use this formula. We're going to use it in terms of physics. Now, I need theta. So tan theta is equal to f res in the x direction. That's going to be 55. And f res in the y direction, that's going to be 33. Okay. Now what we're going to do is we're going to say shift 10 in your calculator, and what you should have in front of you is theta is equal to 10 minus 1, 55 over 33. And let's see what you get for theta. Alright, so what you should have gotten then is you would have gotten 59.04 degrees. Now look at where theta is. Here's your angle up here. So you can say, therefore, so now you're going to write directions. You can say, therefore, f res is 64.14, your statement, newtons. And you can either say, at a bearing of 59.04 degrees, or you could say north 59.04 degrees east, or you can say 59.04 degrees east of north. And that's where we mark your final answer. Now, if I chose, for example, to use the other triangle, okay, so in the other triangle, so I'm using this triangle now, I'm still going to go tan theta is equal to opposite over adjacent, but here my opposites and my adjacents change. So tan theta is actually now equal to f res in the y direction over f res in the x direction, and then theta is equal to shift tan, which is 33 over 55, and theta is then equal to 30.96 degrees. So just remember here, it's going to be 33 over 55. Okay, it's changed. So that means this angle here is 30.96 degrees. Now when I write the statement down, I will still say F res is equal to 64.14 newtons, and then direction I can say at a bearing. See, now if I'm using bearing, I must take 90 degrees minus 30.96, and I should get 59.04 degrees. So I can see now that in terms of bearing, no matter which calculation I use, I still got the same answer. Or you can say east 30.96 degrees north, or 30.96 degrees north of east. Either way, both answers are correct. You must make sure that when you do questions like this, you have a final statement. There's your two final statements. They're exactly the same. They mean the exact same thing, but it's whichever angle you find. That will depend on your calculation. So let's just go through the steps there. Step 1, write down your information. Step 2, choose a positive direction. Step 3, resolve each force into its components. Done. Make sure you put directions next to them. Very important. Don't leave those directions out, because number 1, you will lose marks, and number 2, when you do vector addition, you're going to have a problem. So you do it one time when you sort it out into its components. Then you do vector addition, and that's to find. So what we want to do in vector addition is find the F res in the x direction, and we want in the y direction. We want both of them. Once we've got those two values, we make sure we write their directions, because straight from there, we're going to do the last step is find the resultant vector plus the direction using Pythagoras, and we're going to use trigonometry. So depending on how you draw your diagram, once you draw your diagram, if you can find out where theta is placed, that will help you find the opposite and the adjacent, help you with your calculations for direction and magnitude. We are going to use Pythagoras, and that is how you work with multiple vectors like we've been doing graphically, but now we do it mathematically. This is the correct way in which to do it mathematically. And that's that. So I'm going to put up a few examples, and what I want you to do is for homework is I want you to resolve those vectors into their components. And you will notice that the vectors, when we give them to you, are tail to tail. That means all the tails are sitting on the origin. Then we've got to sort each one into its components, then add up all the x's, add up all the y's, get a new triangle, and then from that triangle, do Pythagoras, do trigonometry, and get to the answer. Okay, so this is your homework. You've got 9 questions to do. The first 8 questions are basic. I've given you an F res, A, B, C, and D, and each of them are in an angle. And what I want you to do is, for the first 8, I want you to resolve these into components. Make sure you draw this diagram in your book, and next to the diagram, you do all your calculations. Okay, I want for both of these, what is the fx and what is the fy, and you can use those two new formulas I showed you. So you've got 1, 2, 3, and 4, and then you've got 5, 6, 7, and 8. And all of these, I'm going to get 2 answers for each of them, because there's only one F res that's been given. Every F res that is given will have, every F res that's given at an angle is going to have one fx and one fy. So each of these should have 2 calculations for each one. And then there's a challenge question here, question 9. Question 9, what they've done is like we did in the previous example. In the previous example with Joe and Pete, there were two of them pulling in two different directions at an angle. Here you have three forces acting on a point, and what we want to do is find what is the F res. So it says three forces, F1 of 4 newtons acts at 60 degrees to the negative horizontal axis. F2 is 1 newton acting at 30 degrees to the positive vertical axis, and F3 is 2 newtons acts at 30 degrees to the negative vertical x-axis. So like we did the Pete and Joe one, the hint is first solve everything into components. So you have an fx and an fy for each of these. Then you do vector addition to find f rays in the x direction and the y direction. Then you get a final triangle, and you can use that to find the magnitude and direction of the final f rays. And we will mark this on Friday.